Hey guys, welcome back to D-T-lite channel. So in my previous video, we have discussed about double sort algorithm, and in this video, we are going to see how selection sort works. For that, I have taken an array of elements which is 9, 7, 10, 6 and 2. All you need to do is just sort this array in ascending order, and we are going to use selection sort to implement that. Basically, how selection sort works is that it will split the array into two halves. One is for the sorted subarray, another portion is for the unsorted one. You need to pick a minimum element from the unsorted subarray and insert it into the sorted subarray. Finally, we'll be having an array which is a sorted one. Let's see how it works. In the first pass, let's assume the first element, which is 9, to be the minimum element. You can also consider any other element to be the minimum one. 9, which is the minimum element here, will be compared to 7. 7 is lesser than 9. So the minimum element will become 7. Again, it is checked with 10. 7 will be lesser than 10. Hence, it remains the same. 7 is compared to 6. 6, which is lesser than 7, becomes the minimum element. Again, 6 is compared with 2. 2, which is lesser than 6, will become the minimum element. At the end of pass 1, 2 and 9 gets interchanged. We'll be having an array like this: 2, 7, 10, 6 and 9. 2 will be in the sorted subarray. The remaining elements, which is 7, 10, 6 and 9, will be in the unsorted subarray. Again, you need to identify the minimum element from the unsorted subarray. 6, which is the minimum element here, will be compared to other elements. And at the end of pass 2, we will be having an array like this. 6 will be pushed to the first part of the unsorted subarray. Hence, here 2 and 6 will be in the sorted subarray. The remaining elements 10, 7, 9 will be in the unsorted subarray. Again, we need to identify the minimum element here in the unsorted subarray. 7, which is the minimum element here, should be pushed to the first part of the unsorted subarray. Hence, at the end of pass 3, we will be having an array like this: 2, 6, 7, 10 and 9. As you can see here, 7 is pushed to the first part of the unsorted subarray. Now, the sorted subarray will be 2, 6, 7, and the other elements like 10 and 9 will be in the unsorted subarray. Again, you need to identify the minimum element here. 9, which is the minimum element, will be pushed to the first part of the unsorted subarray. Here we will be having the sorted subarray as 2, 6, 7 and 9. At the end of pass 4, 10 will be in the unsorted subarray. As you can see here, there is only one element in the unsorted subarray. If there is only one element in the unsorted subarray, it is always assumed to be a sorted one. Hence, the final sorted array will be looking like this: 2, 6, 7, 9 and 10. This is how selection sort works, guys. Let's see how it is working in code. I have taken a piece of code here. The number of passes required to do this process will be 4. That is n minus 1. Here the number of elements is 5. So it will be n minus 1, which is 4. So totally number of passes required to do this comparison will be 4. Here I am assuming the element which is at the 0th position to be the minimum one, which is 9. It gets compared with other elements. So I have taken j as I plus 1. It gets checked with the next consecutive elements, which goes up to n. Once if an element is found to be lesser than the minimum element, then that element will become the minimum one. Again, the process continues. At the end of this for loop, we are checking whether the minimum element position is not equal to ith position. Here, the minimum position will be 4, 0, 1, 2, 3, 4. 2 will be in the minimum position, and 9, which is at the 0th position, will get interchanged. At the end of pass 1, we will be having an array like this: 2, 7, 10, 6 and 9. This process continues, and at the end of pass 4, we will be having a sorted array, which is 2, 6, 7, 9 and 10. Let's see what happens while running this code. I've taken the array of elements here, which is 8, 3, 10, 4 and 2. I've written the sort function here. There are two for loops, one which goes up to n minus 1. The number of passes required will be 4, and we are checking with the next consecutive elements which goes up to n. And I'm doing the comparison here, and also I'm doing the swapping here. Let's see what happens while running this code. As you can see here, the array gets sorted. The output will be 2, 3, 4, 8 and 10. This is how selection sort works, guys. The time complexity for this selection sort algorithm will be big O of n squared. This is because the first for loop will be executed for n times, and again the second for loop will be executed for n times. So the time complexity will be big O of n squared. This algorithm is not preferred because it is a very slow algorithm. For that we will be preferring quicksort and merge sort algorithm, which we'll be discussing in my upcoming videos. That is all for this video, guys. Hope you all enjoyed my video. Hit the like button, share, and please don't forget to subscribe my channel. See you all in my next video. Bye.